The fractal universe is a theory of everything that I've been working on for nearly 5 years. A theory of everything unifies relativity and quantum mechanics. It's the holy grail of physics. The standard model of physics is very complicated. Maybe there's a way we can improve upon it. First, the universe has two states, energy and spacetime. Energy is not a particle, but a volume. Energy is constantly moving and displaces spacetime, and spacetime steers energy. Together, they give each other structure. This displacement compresses and stretches spacetime, causing it to have different pressures. These pressure waves through spacetime have harmonics, and they do different things. You can think of energy going through spacetime like bubbles going through water in a fish tank. In fact, here you can even see that the bubbles form a wave effect. Let's try this out in the simulator. We can see energy displace spacetime sideways. A wave shape starts to form from minor imperfections in the simulation. Eventually, it becomes unstable. More energy creates stronger displacement. We can create a black hole. Alright, so next we're going to show the top and bottom of the fractal. And wait a second, is that a warp drive? Wait, go back. Okay, that really looks like a warp drive. And now there's two? And what, you turn time to 0 and it stops moving, but you turn time back on and it moves again? That's totally a warp drive. Alright, well, all you big bangers out there, I hope you've been wearing your brown pants, because you're going to need them. Basically, the universe didn't explode. It's not expanding into something, it's subdividing. Instead of x, it's 1 over x. And if you think about it, you're inside the universe. Of course, you're going to see everything inverted to how they really are. So before the universe did its subdivision, you can see that we have a inverted donut or something that formed beforehand. At least based off of my model here, that's really buggy, to be honest. But you know what? The big bangers are... Oh, that kind of looked like a big bang right there. Don't celebrate too early, big bangers. I'm going to show you that the universe is subdividing, and I'll show you how it's subdividing too. Alright, first let's go ahead and give us a little more space to work with now that the scale has changed. And now that we resume and... Wait, where's the displacements? No, that's not working. Well, it worked a little. Is it this? No. Wait. Oh, we have pressure. But there's no pressure right after the Big Bang. There we go. Alright, now that we have a few cosmic colons, let's go ahead and fill it up. So a pattern is really starting to emerge here, which is that the stability of things in this universe are dependent on the outward pressure pushing in on it. So we're starting to see a pattern emerge where it seems like pressure determines whether or not something's going to be stable. But where does this pressure come from? Why does supposedly empty space have pressure? Well, we'll see. As you can see, everything's sort of spinning around, and as it spins around, it's imperfect. It's not a perfect circle, and it causes these disruptions in space-time. And these disruptions increase and decrease the pressure in waves. These propagate through space-time and ultimately create the pressure waves that determine the stability of the structures within. So these pressure waves that will destroy a structure in space-time don't come from their neighbors. It comes from a much, much larger object. Think about like a tsunami, for example. That's what's destroying your buildings, not the little water from the kid who's splashing in the puddle. At the galactic scale, you get the pressure from the neighbors, but it's not very much. Too much energy in one spot, and everything falls apart. Whether pressure is a lot or a little depends on the size of the energy. As energy breaks apart into smaller pieces, the opinion will change. Now, when you look at the controls, you'll notice that there's one called forward resistance. Now, what that means is that as energy propagates through space-time, it does it kind of like a knife. And so, or maybe like a raindrop. And the effect of space-time is that some of it goes forward, but a lot of it actually gets splattered sideways. And so that forward resistance is talking about how easy it is to push forward versus having it have to go off to the side. And that's what you saw there when everything fell apart. So here we can see we're in some sort of middle ground on the fractal where nothing really wants to happen, stuff just kind of propagates through it. But as we increase the forward resistance and displacement strength, which seems to be a trait as we get smaller and smaller, we start to get what looks like an electromagnetic field. When you increase it more, you start to see structures form. This looks to me like electrostatic pressure, otherwise known as friction. Actually, I wasn't quite ready to show you that yet. Let's back it off a bit and hit something a little more intermediate. So you saw the flashing colors, which is what happens when things start to hit the effects of relativity. Here you can see structures forming and everything sort of just self-assembles. This reminds me a lot of molecules. So you can see that they kind of form, they're a little bit pokey, almost like Tinker Toys. All right, so the pattern's been that as we get smaller and smaller, you get things that have more stronger relative displacement and also more general pressure. So I guess if we want to crank everything all the way up, let's go check out the quantum realm. Or as I like to call it, the wacky realm. Although, this actually doesn't seem that wacky. All right, so everything's sort of just leaving trails, and it kind of looks like a neutrino detector. All right. So this isn't really aligning with the wackiness that we know about the quantum realm. What if we get increasing the pressure doesn't do anything? Why don't we try maybe things sort of like go full circle and we're back to no pressure again. Let's try that. Okay. So the distortions are sticking around. That's kind of wacky. Okay, now things are getting pretty chaotic. Spacetime's getting so folded on itself, I can't even make out what's happening. So I think this is a case where the simulator sort of breaks down because it's using particles, but in reality, if you can imagine, this is volumetric. So imagine what bizarre shapes this stuff would start forming. And if we increase the effects of relativity's time, you can see things really do start to look pretty wacky here. Maybe there's like an optimal energy size that makes things the wackiest of them all. Okay, so now we're starting to see something that really resembles folds, really crazy ones. At least until it gets a little too out of hand. So we got to fix all these folds. Let's go ahead and increase the pressure again. So let's rewind to our fundamentals. We said that the universe is in two states. One state is space-time, and the other space state is energy. And energy is volumetric. But the simulation has been using particle physics. Everything is represented as a single point. So when you get to the quantum realm and you see these distortions that would most certainly have been within the space occupied by energy, the energy itself would lose that particle shape and actually resemble maybe a string or like Play-Doh when you squeeze it. So it would be going in many different directions. And one theory that I have is that this distortions in space-time is pressure. So this whole time we've been talking about space-time and space-time having pressure, but we didn't really have a clear idea about what pressure even was and why space-time had pressure. And I think this is it. So basically, it's almost like a mechanism to release this problem. And for lack of a better term, it's a pressure release valve for there being not enough pressure. And if you told me that the quantum realm has been, through experimental evidence, found to alternate between these states, that would make a lot of sense, and it would also explain wave-particle duality. And so when you rewind then back to the creation of the universe, you notice that the Big Bang, as it was, required pressure to exist in order for it to happen. So let's say pressure didn't exist. What would have happened then is that this energy forms, this energy then shortcuts straight down to the state where it's folding in on itself, and that creates the pressure that then sends everything squirting in all these different directions. And evidence to support this would be that you would find that the cosmic universe would probably look like an entanglement of lines or a web or threading or something, because it's getting squeezed, and that's just the directions it would want to go. A downstream conclusion of this then is that the universe is constantly oscillating between these two states, and energy is constantly being squeezed, and then that releases the pressure by causing all this energy to spread out. After the energy spreads out, the pressure gets relieved, and this stuff starts aggregating itself again back into little balls, as we saw at the higher scales. And then as those balls get too tight, it squeezes again, like this. Thanks for watching. Don't forget to like and subscribe. In some future videos, I'll talk about dark matter and dark energy and how they are perfectly well explained using this theory.